Hello everyone, this is video number 1 for lesson 9.2. In this video, we'll be talking about multiplication principle. Okay, so multiplication principle states like this. Suppose we have n choices that we need to make. Okay, so suppose n choices must be made. N could be anything, any whole number, with M1 ways to make choice 1, M2 ways to make choice 2. In M1 and M2 could be any number. Up to Mn ways to make choice n. So so it could be M3 choice 3, M4 choice 4 until it reaches Mn, whatever this n is, to make choice n. Okay? Then, so suppose this will happen. Okay? So then there are M1 times M2 times M3 times M4 until it reaches Mn. So depending on your n. Different ways to make the entire sequence of choices. So this is the multiplication principle. Okay? That's how it is. Okay, so I prepared 3 examples here for you guys. Start with the easy one. Okay, so let's start with example number 1. According to the example, it says right here, if there are 3 roads, so 3, that's very important. Highlight that. From town A to town B, and 2 roads, so highlight that because those numbers are very important, from town B to town C. In how many ways can someone travel from A to C by way of B? So meaning you're from town A, you're gonna go to town C, but you have to go through town B. Okay, so let's draw that. Okay, for example, this is town A. This is town B, this is town C. To go from town A to town B, you have 3 roads. It's either you go like that, you go like that, or you go straight. And let's label that, say, A, B, C. And then to go to from town B to C, there's 2 roads. So it's either here or here. And let's label that, let's say 1 and then 2. So what are the different um, ways? So how many ways? So let's start with that. So let's say start here. A1. So I'm gonna have A1, small letter A1 because that's the letter they use. So A1, and then I can also say A2, right? And then because from A to B, I use this road. Then there's 2 choices. It's either I use 1 or 2. So A1, A2. Then let's say B. I can go B1, then B2. Right? So when I get here, I can either choose this route or that route. Okay, and then C. A to B, I can use C. Then when I get here, I can say I use road 1 or road 2. So I'll say C1, C2. And how many do I have? 1, 2, 3, 4, 5, 6. There are 6 ways. Okay? But you cannot do this if the numbers are big. Let's say if This is not 3. Maybe this is like 50. And this is not 2. Let's say this is like 85. So how can you do this? It's impossible for you to do that. That's why this multiplication principle will come in. In other words, if you look, if you multiply, let's say our M1 is the 3 roads. And then our M2, M2 could be 2 routes. Okay, so if you multiply that, M1 times M2, then you can say 3 times 2, you're still gonna get a 6. So you have 6 ways. Alright, guys? So that's one way. We're gonna avoid this because it will gonna take you forever. And it's not practical to do that. Okay, let's try number 2. Okay, so in number 2 we have 9 skirts. Okay, so let that be your M1. And then 8 blouses, so that would be your M2. And then 13 shoes, so that would be your M3. Now, if she is willing to wear any combination, so you're gonna make a combination of skirt, blouse, shoes choices. Okay, how many different ways can she do that? Well, can you imagine if you draw a diagram on this? It would be a lot. Since we're asked how many different combination, I can say M1 times M2 times M3, and that will be 9 times 8 times 13, and then you use your calculator on that. So 9 times 8 times 13, and that would be 936 different combinations. Different combinations. So that would be your answer right there. Okay, and then the last example I have here, a combination lock can be set to open to any 3-letter sequence. So 3-letter, that's very important. And it's a letter. We're gonna use the English alphabet, and you know there are 26 letters in the English alphabet. So let's say, for example, first letter, the first, the second, and then the third letter. So I'm gonna pick the first letter. I have 26 choices because there's 26 letters. And then I'm gonna pick the second letter. There's also 26 choices. Then I will also pick the third letter. That also be also another 26 choices. So there are how many sequences that I can have, and then that would be 26 times 26 times 26, and I will have 17,576 different sequences. Okay, and then the last one, letter B, how many sequences are possible if no letter is repeated? Okay, that's very important. Okay, no letter is repeated. Okay, again, first letter, second letter, and then the third letter. Okay, the first letter, I have 26 letters available to me. Well, I pick one, right? Now, for my second letter, I cannot repeat what I pick, so the only available to me is 25 letters. And then the third letter, I have only, I cannot pick what I pick in the first one. I cannot repeat what I pick on the second one, so therefore I will have only 24 choices. So then you multiply this. That's because no letter is allowed to reuse. You cannot reuse the three letters. So therefore, you're gonna multiply. You're gonna use that. Then multiply 26 times 25 times 24, and you will have 15,600. 15,600 sequences. So you see, it's lower now than the first one, because in the first one, no, you're allowed to repeat. It doesn't matter if the number will repeat. I mean, the letter will repeat. It's okay. That's why the number of sequences is higher than the second one. Or this is letter B, huh? The second one, because you cannot repeat. Okay, guys.